an independent researcher, I would say. I work as an artist, and I've been interested in environmental literacy for a long time. Our human capacity to learn about natural systems and nature, but also how non-humans learn, including animals and plants, but also machines. How do machines learn about the environment? So a lot of my practice is landscape-based, where I try things out in situ. So this is investigating the way of sort of trying to get a sense of how whales who communicate by sonar, how that feels. So I go into the water and I make a small speaker that plays the sound of that sonar, made lower so that I can actually hear it, of course. So it's a way of research that's quite embodied, and what I do is I do quite broad research, and one of the first things I built after graduation from my school was I made one of the first apps that related to nature, and it was made to show edible plants in your area. And when we were making this, the people who funded our program asked, okay, but so you are showing edible wild food sources in your area, or globally actually, and how do you make sure best practices are observed? So if somebody in Italy puts mushrooms on your map, how can we make certain that all those mushrooms aren't picked? Or what happens if somebody puts an endangered species on your platform? So I started to ask around, what are best practices? And I couldn't really find much because at that time, collecting environmental data was very much still in the realm of university and sciences, and not so much in the public domain. So these were the first moments when environmental data were entering the public domain, not just showing them, but also gathering those data. And I got a bit concerned actually about those best practices, about the role of technology opening up the worlds of non-humans, of plants, of animals. And it was confirmed by this photo that I saw on Twitter. No, yeah, on Twitter in I think it was 2013, where it shows a photo from a safari vehicle, and it's a notice that says, that warns safari goers, please, when you make photos on your safari and you put them online, don't include the geotag, because poachers are hunting our rhino through those databases, through those online photo. So that raised my concern even further, and I started to make programs that sort of look at technology and nature, which started actually in Finland with a presentation at Pixelake, which is a cultural festival in Helsinki in 2011, where we looked at sort of the first contours of environmental data in a public setting. So you see a little photo from that. I started to make field-based research programs with small teams, interdisciplinary. And here you see Antti Tenets, who is Finnish, at Kilpisjärvi Biological Field Station, where we were doing research with a small team for maybe 3 weeks, invited by the BioArt Society of Finland. And what we did is field experiments. I'll show you some examples. So This is the other team member, Ian Ingram. And Ian builds robots that try to communicate with wild animals. This is a robot that tries to communicate with squirrels. It can recognize, it has a small camera on the front of it, and it can recognize some of the, let's say, enemies of the squirrel, humans, dogs, and birds of prey. And when it sees one, it gives an alert. It sort of shakes the tails, because that is an alert signal for the squirrels. And you see the squirrels running into the trees. Now, this is a project he built in 2009. So Ian was already using image qualifiers back then in small robots that he built to do experiments. And in Kilpisjärvi, he worked on this robot, which tries to communicate with wild crows. It can spot them. Once it spots a crow, it starts to make a signal. It's not a sound signal, but a signal through movement. When crows communicate through sound, but also through movement, and one of the signals that Ian is interested in is the beak wipe. So the bird wipes its beak across a branch, which is what this robot can do. And it's biologists say that it's a signal that sort of shows a stress. So the crow needs some time to evaluate the situation. And Ian thought it's a great first contact for my robot to be able to say that it doesn't quite know what to do. Next year, this will be a larger program in the local zoo in Amsterdam. Machine Wilderness is that program, and Ian will work with the Victoria crown pigeon to analyze, which is the biggest pigeon in the world. So he makes a translator robot that looks at the behavior of this animal and then translates that to the pigeons outside, the normal street pigeons. They don't need a translation machine, but it's interesting to do it anyway. Spela Petric is also participating in that program in the zoo. She is making a system where an AI and a plant grow up together, mature through playful interaction. So these little blue balls you see are part of that game. And she's also interested in the power relations between humans as caretakers of plants or humans as caretakers of nature, and the way this is changed by AI, by machine learning. Does that change the balance? Are humans put in a different position when there is also machine learning involved? Also part of the program are Driessens and Verstappen, who made this machine that analyzes sand grains. The sand moves across the machine and passes by a small camera, and it analyzes the sand grains for faces. And the Dutch beaches have the best faces in the world. This is Erwin in the zoo. They'll be working on this system they've built, which is a camera, and you see him working at his programming the computer. This camera looks for birds, and it makes pictures of them. Each time it makes a picture, it's forgetting its initial training data. So in the beginning, Erwin, who's sitting here, gives the machine an amount of pictures of birds, and during the process of learning, the machine forgets that initial set. And in the back, you see two monitors where you can follow a visual representation of what the machine thinks a bird is like. And that is evolving. There's a long history of artists looking at the environment through landscape painting and all those kinds of traditions. This is continuing that tradition. So Erwin has to teach the skill of observing nature to the machine each step. So he builds it basically almost from scratch. Here he is using a roll of tape and dangling it around to train the machine to spot something that moves, because birds move. So each step is part of the work. Another program I organized was Random Forests, and that looks at environmental machine learning, where we work with a group on an island in the Netherlands, and we look at, we sort of try and see, okay, if machine learning is going to be part of the way we inform ourselves about landscapes and take care of landscapes, can we look for a place like an island that is quite finite, it has clear limits, and see, and we spend a week seeing what if an artificial intelligence had to make sense of this island. What would be its information sources? And in those information sources, what are the present biases, the caveats of which things is there much information, on which things is there little information, to sort of figure out the terrain from the viewpoint of an AI. And part of this team was Paul Seidler, a young researcher from designer from Berlin, who is building a project called Terra Zero, where they take a plot of forest in Germany and they form a DAO for this forest, a decentralized autonomous organization. And that organization starts to trade on the financial market. Through a sensor system, the forest is directly informing the process of trading on the market. Can, over time, this forest make enough money to buy itself back? That is sort of the concept they're trying out. And then I'll go a bit quicker. Here we see anti-tenets again, because in speaking to people about machine learning, you sort of see that there are a few things, there are many issues, and one of the issues would be that people who work in between field ecology and policy say that, at least in the Netherlands, there's a tendency to maybe go more for policymakers to look more at models and sort of less, and as a way to bypass the individual expert, because an expert might say, have counterexamples or have questions or make comments, where a model will just produce an answer. So one of the things we asked is, are these is machine learning becoming, in a way, a policy machine? Other questions were raised about who our experts are. So during our research in Finland, we also asked people like this reindeer herder what he would use machine learning for, basically what it is, and then what it would make sense for him to use. And the same I would ask to indigenous peoples of friends of mine in the rainforest in India, where I visit often. And I talk to them. They are, for centuries, for a very long time, they've been inhabitants of forest. They have a very complex relationship to that. And then talking to them about environmental stewardship and how technology could aid that is very informing. They have very different ideas about what it means to manage or be a custodian of an ecosystem. For instance, they say we are not just custodians of the physical environment, but also the spiritual environment, and they cannot really see where machine learning could aid them in that. But they're very interested in learning about these systems. I'll leave it with that because I think I'm pretty much over time.
Thank you very much, Toon, for very interesting talk, and it was nice to hear a little bit different from different aspects of where to use machine learning. Thank you. Let's try. Yeah.
Maybe I would just say that Antti Tenets, who is often a collaborator, is an artist who works in Finland and is working with machine learning. So he might be interested to join your meetings.
Okay, that's good to know. So is there some quick questions or comments? Eero?
Well, thank you for the very thought-provoking and also fun presentation. I would just like to ask, like, if you would have some word of advice, because you work from you look at this topic from very different angle than the people who are developing these algorithms, and like. So would you have some piece of advice or because you have worked on these topics for like tens of years? So.
Yeah, I think it's interesting to place the discussion in a cultural setting like I do, and it enables other people to be involved. And what researchers, let's say, who are more on the technical side, say to me is that it's for them interesting to participate because it's a less technical discussion and more a discussion about why are we doing this, less than how are we doing it. And the why is quite easily accessed by other people. How is for experts only, I guess, but why is quite open.
Thank you, Teon.
Yeah, thanks.
Interesting. I think we will now have Nitin's presentation, and it looks like it's working now, so please.
Thank you for being patient, everyone. And this is a really nice combination with Theon's talk. I'm actually really delighted to see Theon. I was very much at the beginning of this foundation of foam in the late 90s when I was in Brussels at Star Lab when Maja Kuzmanovic was establishing this, and we had a lot of good conversations, and I came many times to visit her and the team in Brussels. So it has just really done such remarkable work over the years, and I'm looking forward to connecting with foam again now that I'm living in Helsinki.
So, thanks, Nitin.
Yeah, it's really fabulous. But you know, this is great because a lot of the discussion I would like to have now, it builds on this, and I think hopefully we can go forward from there. So I wanted to bring up issues of ethics in urban and environmental AI. I teach courses on ethical AI and critical AI, and that's one of the reasons I was invited by Laura and Eero for this discussion. And I want to bring maybe some conceptual ideas building on some of Theon's work, but also some practical ones that maybe we can go. And I'll try to be relatively quick because we are at the end of the day. So. So some definitions we generally get of ethics tend to deal with moral obligations and duties of humans, and also the behaviors and actions of us as groups. And there are many areas of study that we talk about in ethics, machine ethics being one of them, but also environmental ethics. And I often talk about the many aspects of ethical theories that we should think about, from consequentialism to emotivism, intuitivism, which all have many different frameworks. But situational ethics is what we often, I think, focus much more on because it tends to think about the context within which we are working and how we are making the right decisions in those contexts. But environmental ethics as a field is a bit younger, and it tends to now focus more on extending the traditional boundaries of ethics from humans to thinking about the non-human world and what could be the rights of these non-human entities, be those animals or our ecological entities around us. So going into kind of the machine learning context, we saw many different models and approaches for machine learning in the talks today. Reinforcement learning was something Laura talked about, and supervised learning is something we've seen quite a bit as well, and so on. But each of these obviously assumes that there are certain ways that you can deal with bias and handle them ethically in those contexts of use. One of the projects that one of my students was doing when I was teaching at MIT over 10 years ago was around thinking of how to use environmental data to make sense of both carbon monoxide and noise pollution in our cities. And one of those ways was to create a network of bicycles around the city that would essentially use these sensors as people riding their bikes. And of course, sensors are also embedded in the helmets. And so Actual Air was a project that Michael did for his thesis work, where he was trying to work with a number of participants to gather this kind of environmental data over time, visualize it, both actually in place on his bike wheel and also for kind of citizen engagement, but also with the data sets themselves. He was gathering both baseline data from the city, but also data from multiple cyclists. And then they were going to sort of try and do some modeling of the data to forecast at different times of the year what could be potential levels of pollution or environmental noise in the city. Now, typically the machine learning workflow, as we've talked about in the most straightforward kind of supervised context, is where you have data, training sets, testing sets, you then do evaluation, modeling, and prediction. But ethics comes into every stage of that process, because at every stage we could be doing something that could skew or bias the process, from the objective functions we use to the actual data we use for training or validation, and so on and so forth. So we talk about all of these challenges of the messy data that we have to constantly deal with, and in fact, with environmental data, it gets even more complex, and how we have very ambiguous models and insufficient evaluations to do very quality predictions. So, where does that lead us? So we have to think about, and I can give a whole lecture on these kind of 5 classical, which is what I often do, kind of concepts within ethical AI: bias and fairness, how we deal with accountability and remediability, trust, transparency, and so forth. Now, how do we bring this framework into the environmental context, where we're dealing not only with human accountability, but accountability to the non-human elements? What kind of remediability do we offer to the environment? How do we make ourselves accountable to that? How do we make sure this is transparent? It's safe for long term, not safe like in the current horizon, but safe in the next 100-year horizon, what we do, and so on and so forth. And how do we align our values, not just with what humans need at any given time, but what the entire ecological impact of that work will have to be? So I think the field of AI and sustainability, as Laura was saying, is quite young, but the field of AI and environmental ecology is even younger if we take a broader worldview of this, when we include human, non-human, animal, and artificial entities in this larger sphere. So I won't go into all of these different components because I was actually going to hide all of those slides because I thought there was just too much for us to discuss. But I want to talk briefly about the kinds of things we can do in terms of oversight, governance, diversity, inclusion, and more participatory ways of doing this. And a paper that I wrote recently, which will be published in the Journal of Cultural Knowledge and Communication, which is part of AI and Society, was around urban AI. What kind of risks, rights, and responsibilities we have in this context. And a couple of case studies I bring is also from data we used in New York City in the urban context from bicycle sharing systems and the kind of contestations that come up when you have data from different mobile systems that citizens can't access, and how do you make decisions about these issues together in civil society. But one of the other things I bring up is what's happening with the new AI Act that's being proposed by the European Commission, which is looking at both medium and high-risk AI, and what kind of framework we can use to regulate that. And this is really important in the environmental context because there will be some high-risk scenarios of use of AI in the environment that we need to think about. If we have really good systems for modeling tree growth in forests, how are we using that data in a regenerative way to support the forests themselves versus allow more wilding and allow forests to have some control over their own agency? So if we are taming forests for our own needs, is that a high risk to the forests themselves? These are kinds of questions we have to grapple with if we think about the broader ecological framework. This was actually one of the case studies I used from the city of Amsterdam, where we look at the use of ethical AI from a public sector context. Here we look at these cars that are being used in the city of Amsterdam to detect license plates that may be for illegally parked vehicles and so on and so forth. And they actually put their whole process flow. They talk about what they do, but you can see already when you analyze their process that there could be real issues of accountability where data that they use to track certain people's license plates could be used in a way that would cause civic rights violations. And so what my team is doing is actually understanding what are the implications of these new regulations on these public sector AI systems to really make them more transparent, accountable to citizens themselves. So rights, risks, and responsibilities are really crucial, but so is inclusion, participation, and agency. So I'm going to transition very quickly to the second part of my talk, where I want to talk about what we think of in the context of the environment. So let me see if I can play. Does that play? No, it doesn't play. There was a video that I was going to show you, but it deals with kind of how Indigenous communities in New Zealand are think about a river that they have some stewardship over. It's very similar to the example Theon showed us from Indian conservators who have the sense of both spiritual and ecological responsibility over their own environment. And how does the river have any agency in this? So in New Zealand, actually, they gave that river legal personhood. So it has rights. And with these rights comes responsibilities from the different stakeholders and actors who are using the river, are part of the river, and so on. And so this was a very fundamental and important legal intervention that allowed us to think about this in a very different way. And so we have to think about these different ecologies in society. The kind of constructed ecologies are what we're mostly used to, the infrastructures and systems we build, but there are also ecologies of values that we bring, and maybe values of other systems, other entities, ecologies of power, who actually has power to determine what happens, and this larger sociocultural context within which we are working. One of our students at Alto actually did this kind of ecological mapping for wildfires, looking at how you think about it in the environmental context, the sociocultural space, and where the design space is to do intervention. And many of you are familiar with this diagram from the anatomy of AI, which looks at the role of devices like Alexa in a much more ecological perspective. Everything from where the machine learning is done to where the data is trained from servers in Bangalore to where the mining is done for building the systems to the labor. If you take this larger planetary view, you start to see how the ethics becomes so much more complicated in the system. So kind of on the last section of what I want to talk about is what can we learn from indigenous perspectives? There's been some really interesting developments in the last 2 years where indigenous researchers in Canada, in Australia and other places are coming together to think about these questions in a much more interesting way. And one of the papers that they put out recently is called Out of the Black Box, Indigenous Protocols for AI. So protocols are kind of a indigenous term for how you think about practices like stewardship, for example, and ways of actually engaging ourselves in a system. And one of the nice things that comes up in this paper is a comparison of terminologies, terminologies that we use in the indigenous context of terminologies we use in a computer science or machine learning context, and how can we kind of calibrate them to understand, to align these practices with different perspectives. Another diagram they show is this kind of Western worldview versus the indigenous worldview, where humans are very much part of this network of entities rather than kind of having power at the very top. And if we change that worldview, it makes us think about redesigning our systems very differently. So one of the practical consequences of their white paper was, their position paper was this kind of guidelines for indigenous centered AI design, where they think about the locality, the contextual local context within which you design systems, the relationality and reciprocity you bring to it between other users and non-users of the system, responsibility and so on, and governance guidelines, but also how you think about data sovereignty and ethics in a much more broader context. One of the things I liked about their process was also the life cycle of an AI system. Everything from when you build it to when it's ended, and how technologies also you have to design for how they're terminated and recycled and reused. So they think about the whole life cycle in a very interesting way. So you can see some more in the paper, maybe more analysis of their perspective. So, you know, in the course that I taught this spring, that Laura and Eero were also part of, we talked about a number of these kinds of issues and unpacked them quite well. And you can find the readings, you can find the blog discussions on our site quite easily. And one thing we did towards the end of the course that I really enjoyed was that we analyzed the papers we were reading and who wrote them, what perspective were they bringing. What was the gender balance? What, you know, which countries were they coming from? What was the ethnicity of the authors? And obviously, you know, it's very clear that the West dominates the discussion of AI, but there are really important indigenous scholars and researchers in the global South that we can bring into our discussion. And in fact, I invited many of them to speak in our course and also to bring their perspectives on feminism, on indigeneity and decolonizing how we think about these issues. So I think we in the university have to think about reframing our understanding of AI and ethics in a whole nother worldview. And that's really crucial. And to that end, I'll leave you with this seminar series that we've started. We've launched just in the fall, and we have a number of awesome speakers already joining us. And next week, we're going to have Aditya Jori, who's a professor at George Mason University, talking about human cognition ethics. And then we will have Sala Maria speaking as well. So I'm hoping we can do much more in-depth critical discussions about this at Alto and elsewhere. So let's end with that. Thank you.
Thank you, Nitin. And I'm very glad that the technical problems were solved and we could hear your excellent talk. And I think it was a perfect ending for our presentations. So thank you very much.
Thanks.
Now for other comments and questions before Otso gives his synthesis.
Yeah, I want wonder if people have questions for both myself and Teun, since our talks were so interrelated, if there was anything that came up. I know that they came from a kind of left field for the typical AI seminars, but I felt it's important for us to just shake it up a little bit and bring some different perspectives into this conversation.
Yeah.
I have a question for you, very practical. Could you share the links to your research also in this chat? Because I wasn't quick enough to write them down.
I didn't bring any links yet, but I could perhaps just put a link to my homepage, because it has quite a few of these projects in one place. So I'll put that while talking. Yeah.
Is it difficult to find what is a typical way of you sort of finding speakers from, let's say, an indigenous context?
We haven't done that here in our seminars, but in fact, this coming week, in 2 weeks, we're organizing, we have a seminar series called The Color of Science. And we have actually tried very hard to bring indigenous speakers into that series. So we actually brought Sami researchers, and in fact, in 2 weeks, we're also going to have other indigenous researchers speaking. So I'll also put a link to that seminar series, because that's been a really important initiative on our part to kind of break out of the Western context of talks we usually have.
Wonderful. Yeah.
I can't see any hands up. Maybe shall we
move on? And once again, thank you, Nitin, for this talk. So next on, we will have Otso Vaskainen, professor and the leader of the Life Plan project, and he has promised to prepare a synthesis of today's talks and ideas. Please.
Thank you very much. I hope you can hear and see me, and let's see if I'm able to share my screen. Yes, I think you can now see my screen. Yeah, we have heard really a wonderful set of talks today, and I was asked to give some reflections and comments on the day as a whole. So let me start by reminding that this was the second machine learning seminar that Luomus and SYKE kindly jointly organized. So this was kind of a follow-up of a similar event that you organized half a year ago. And let me start by reminding what we were listening in the first machine learning seminar that you organized half a year ago. This was kind of my summary slide that I presented in the end of that seminar. So what we really focused on that first seminar was biodiversity research and monitoring, and especially ways on how to get data, how to acquire data on species communities or biodiversity, on environmental covariates, also to some extent on species traits and phylogenies, using image, sound, and other methods. So we really much focused on this, how to get data. And then there was a little bit about policy and management. Many talks were at this interface, but they mostly focused on this, how to get data. And in my summary speech in the end, I said that some things that were missing that would be great to hear about are, for example, how to not only work with image and audio data, but also DNA data, because that's clearly something that's increasing a lot in the research and environmental monitoring, but also how to use machine learning or artificial intelligence to not only to get the data, but to analyze the data for ecological modeling, for example, species distribution models, or making predictions for the future of biodiversity. So if we now look what the talks today were about, we really extended to these areas, but not only to these areas, but also to many other areas. So here is kind of my summary of what we are focusing on today. And I would say that we have this kind of two major areas. We work with biodiversity research and monitoring. I classified some of the talks to this box, and then many talks now went to this nature-human interface, which we didn't focus so much in the previous time. So in addition to this, on how to acquire biodiversity data, Tommy talked about camera trap data and Alessandro about DNA barcoding data. We had these super valuable talks on to how to then model these kind of biodiversity data, species distribution modeling through boosted regression trees. Luisa was talking about that. And then Laura Ustalo talked about the dynamic Bayesian networks, kind of a dynamic perspective on how to combine many kinds of data sources. And this was a really useful extension, something that I was really kind of missing in the previous seminar, and clearly something that you could bring many other approaches to this box as well. But then the major expansion was really in this kind of a nature-human interface. We had talks about policy management, sustainability. So I know in the welcoming words mentioned that these machine learning methods are mentioned more and more in the kind of in the practical management and policy, that we need to apply these methods to find solutions to the biodiversity crisis. They don't solve the crisis themselves, but they are really needed there, and we should really use them for this more practical policy management. And then Laura and the other Laura, described these modeling approaches, how to look at sustainability or environmental risk, and that was really fantastic to see. Then we had really interesting talks, which were a bit difficult to classify, but they're related to citizen science, indigenous perspective, ethical aspects, human-nature relationship. Vuokko talked about nature-related free time activities. How do you look at these from social media kind of data? And then Nitin and Thorne in these last talks, they really brought a completely new perspectives, talking especially about ethical aspects of using machine learning. And Thorne really had a broad range of uses of machine learning in research and citizen science projects that you have developed over the years. All of these talks, they had some methodological aspects, but if I just pick some kind of methodological aspects, I would pick Mikko's talk, where the main point was that you really don't need to be expert to apply these machine learning methods. You can just, they are relatively easy to apply now for anyone. But if you want to go for your very own application where you don't have the ready training data, then you need to train the training data. That can be tedious. Tommy kind of responded to that by saying that if you use these active learning methods, then that typically reduces the need to generate such a massive amount of training data. And as said, there were a lot of other methodological aspects in the talks, but I didn't cover them here. Now, in my last summary, I picked up some major trends, common observations, and actually I didn't update this slide. I think this works equally well for this machine learning seminar 1 and the current one that we have today, the second one. So there's a need for these methods. We have massive data, we can't analyze them manually. Then these positive technological messages that we can do it, that these methods are developing fast, that they are increasingly easy to use. It works in practice. Results are typically almost as good as you would get by expert evaluation, at least when applied to similar test data as the training data. But then there is this broader discussion on, is it really useful? So there are all of these exciting possibilities, but still, do we really take the full advantage of these at the highest level of, let's say, practical policy and management? And now something that I should have added here is this ethical perspective, that we need to think about that in the context of all of these research that we are doing. I'm trying to be fast because we are a bit over time, so this is my final slide. Are there some topics that we did not hear about in this seminar and we might hear about in the next machine learning seminar? So first of all, I think it would be really great to have a broad overview of the current methodological developments in machine learning, because the field is developing so fast and there are so many kind of methodological developments that many of us could benefit, that it would be great to get an overview of that. And I'm just suggesting here that maybe, for example, Graham Taylor, who's one of my collaborators from Canada, could give such a talk. He's a leader of a machine learning group that focuses also on environmental science, but any other kind of a machine learning guru would be equally welcome. And then I think we have already in these 2 seminars seen a really broad range of applications of machine learning in nature conservation and research, and I can't really identify any major resource areas that would still be completely missing, but maybe somebody else can, and if yes, put them to chat so that then the organizers can take those as ideas. But I would more say that these methods, use of these methods is evolving so fast, so I would be really happy just to have these kind of seminars continuing at a more or less regular basis so that we can update us on all of these exciting developments that are taking place. So that's the end of my brief presentation. My main take-home message is that I'm really happy that Luomus and SYKE, you are organizing these seminars, and I just hope that you don't stop here, but you go on and keep this kind of a society going and our communications in this field. Thanks a lot.
Thank you, Otso. That was encouraging and inspiring. I think we might have some questions or comments, even though we are running out of time, but if you are not in a hurry, if someone wants to ask. Aino, please.
Yes, thanks. Excellent wrap up, Otso. Thank you. I'm eagerly looking, waiting for that we get some of these technologies into practical monitoring. And I have a question, or I'm wondering, as the biodiversity crisis is global, but on the other hand, we know that we conserve biodiversity locally. The methods are more or less, I guess, equal or global, or research is done globally. But do you foresee that we need some adjustment for local monitoring, though? Or so that the selection of techniques maybe for monitoring locally would be different, so that we support best the local decision making?
Was this a question for me or for in general?
In general, maybe for you, but for anyone. Have you thought of this?
Well, if I reply from my side, we run this life plan project where we monitor global biodiversity by this DNA, image, and audio methods. And I would say that those biodiversity monitoring methods, these methods, how do we identify the species, what reference databases we use, and all of that's best to do at the global level, because the species, they don't respond to the boundaries of the countries, and that's kind of clear that those methods, I think, should be developed at the global level. But then how then the results are applied then in policy and also like environmental monitoring? I mean, there is this strong interaction with the legislation and all of that is then country specific, and there clearly we need to tailor the methods to what is an endangered species in one country might even be almost like in the extreme case an invasive species in another country. So how do we look at those data is then clearly something where we need the national perspective.
Laura, please.
Yes, thanks. Yeah, I've also been thinking about environmental monitoring to some degree, and I agree with also obviously that it needs to be a combination of global and local. I also think that when it comes to machine learning methods, they are usually quite data hungry on one hand, and also produce a lot of data on the other hand. So that kind of compensates for the data hungriness. But I think I think I find eagerness to kind of replace the old long-lasting monitoring systems by new methods that are kind of cheaper and faster and everything. But I'm a bit conservative about that, because I think as the environment is changing in such a rapid speed, we also need to have these long time series, and we need to be able to compare across decades and centuries if we can. And obviously, if we can really like map the old data series with the new one, so that we can understand how they match, and we can kind of really replace the old one, then that's fine. But if we don't really replace, we kind of change this old one to another one, I think that's probably a bad idea.
I agree.
Are there more questions or comments? Would our organizing team want to say something?
I would just like to thank all of the speakers. I think it's been really interesting again, and thanks for everybody for preparing and presenting, and also thanks for everybody who's been here to listen. I hope this has been inspiring to all of you as well.
Yeah, so thanks to all the speakers, and also to Otso for the wrap up, and for Aino for opening and this discussion. I think it's now time to close up this webinar. Once more, thanks again to all of you, and there will be a recording with the captions provided on the event page later on. Okay, so thank you and have a nice day. Bye-bye.
Thank you. See you again.
Thank you. Bye-bye.
Kiitos. Moi.